19.7 Using heuristics in query optimization. In this section, we discuss optimization techniques that apply heuristic rules to modify the internal representation of a query, which is usually in the form of a query tree or a query graph data structure. To improve its expected performance, the scanner and parser of an SQL query first generate a data structure that corresponds to an initial query representation, which is then optimized according to heuristic rules. This leads to an optimized query representation which corresponds to the query execution strategy. Following that, a query execution plan is generated to execute groups of operations based on the access paths available on the files involved in the query. One of the main heuristic rules is to apply select and project operations before applying the join or other binary operations. Because the size of the file resulting from a binary operation, such as join, is usually a multiplicative function of the sizes of the input files, the select and project operations reduce the size of a file and hence should be applied before a join or other binary operation. In section 19.7.1, we reiterate the query, theory, and query graph notations that we introduced earlier in the context of relational algebra and calculus in section 6.35 and 6.65 respectively. This can be used as the basis for the data structures that are used for internal representation of queries. A query tree is used to represent a relational algebra or extended relational algebra expression, whereas a query graph is used to represent a relational calculus expression. Then in section 17.9.2, we show how heuristic optimization rules are applied to convert an initial query tree into an equivalent query tree, which represents a different relational algebra expression that is more efficient to execute but gives the same result as the original tree. We also discussed the equivalence of various relational algebra expressions. Finally, section 19.73 discusses the generation of query execution plans.